Hey there, chemistry students. This is Ms. Ruark. This is Vodcast 3.4, where you're going to learn how to name acids, write formulas for acids, and you're going to figure out what a hydrate is. Smart stuff. All right. So there are a bunch of different, well, not a bunch. I'm a liar. There are two different main types of acids. There are binary acids, and there are what we would call ternary, or you can call them oxyacids. All right. So how do we know if it's an acid? Because it'll have hydrogen at the beginning of it. If it's hydrogen attached to a nonmetal, such as HCl, we would call that a binary acid. Bi meaning two. If it's hydrogen attached to a polyatomic ion, such as H2SO4, we would call that a ternary acid. Or if it has oxygen in it, you can call it an oxy acid. If it was something as HCN, that would be a ternary acid because there is no oxygen in it. Okay, when you name a binary acid, the name depends on the state of the acid. That doesn't mean Georgia, South Carolina, North Carolina, etc. That means physical state. Okay, physical state. That means that you can have a solid, you can have a liquid. That's a D. Okay, you can have gas, right? Solid would be S, liquid would be L, and gas would be G. Well, guess what? If you take any of those things and you dissolve them in water, you can get something called an aqueous solution. We'll be dealing with those later on. We would symbolize those as AQ. All right, so if it is not aqueous, if it's solid, liquid, or gas, you would name it hydrogen, and then whatever the nonmetal is, you change the N to IDE. So HCl gas would be hydrogen chloride. If it is aqueous, how do you know it has AQ after it? You would put hydro, the root of the nonmetal name, add IC to the end, and then put acid, such as hydrochloric acid. Two different ways to name it. So here's some examples. HBr has an S at the end of it, which means it's not an acid. So we would name it hydrogen. And then because bromine is an element on the periodic table, we change it to bromide. Okay, what about HI with AQ after it? Well, it's an acid because it's aqueous. So we're going to name it as an acid. And we would name it hydro. And then iodine, the root of that would be iode. So hydroiodic acid because we put IC at the end and then acid. All right, this one, H2S, is aqueous, so we would have to name it hydro. Now, sulfur, if we were to take the root of sulfur, we would say it's sulf. But if we called it sulfic, that just sounds silly. It doesn't sound right. So we don't do that. We actually take the whole thing and we say it's hydrosulfuric acid. That sounds so much, sounds, right? Sulfic. It sounds puny and wimpy. We don't want that. Okay, what about H2S with a gas after it? Well, because it's just gas, we would name it hydrogen and then sulfide. And that's it. Okay, well, what if it is an oxyacid? Okay, if it's an oxyacid, you would know because it has oxygen in it. The name does not depend on the physical state, so it can be anything. It doesn't matter. So if it was H2SO4, we would name it. If it was HNO3, we would just name it. It doesn't matter. The only time you have to look at the physical state is if it's binary. So how do we do this? Well, we name the polyatomic ion. In this one, SO4 is sulfate. All right, well, we replace in a polyatomic ion, if it has ATE, we replace it with IC. And if it has ITE, we replace it with OUS. Now, there's a little saying that I have that I remember which one it is. I ate something icky. Yes, it will help. Because I ate something icky. ATE goes with IC if it's not AT. There's a saying for the other one, but I can't remember what it is. So I remember this one, and if it's not this one, then it has to be that one, right? All right, so I have to change ATE and change it with IC. Sulfic. Oh, it's so puny. It doesn't sound dangerous at all. So on 3, it says change the root if necessary for pronunciation. Sulfic. Oh, it bothers me. So we actually say sulfuric. Ooh, that sounds scary, right? And then we add acid to the name so that people know it's an acid. So sulfuric acid, H2SO4. And that's how you name it. All right, well, here's another example. H2SO3. SO3, -2, is sulfite. All right, I ate something icky. Doesn't apply here, so we've got to change ITE to OUS. Sulfus. It just sounds silly. I'm going to write it again. It just sounds silly, right? Sulfus. Sounds like selfish. All right, but we don't like that, so we're going to take it and make it sulfurous. Ooh, that sounds scary. And then we add acid to the end, and there's our name. I know. All right, well, let's try these down here. HNO2. NO2 is nitrite. I ate something icky does not apply here, so ITE gets changed to OUS. Do we need to change it to make it sound scary? No, because nitrous sounds scary. Nitrous acid. I know, we're not changing it to make it sound scary. We're changing it to make it sound proper. Okay, ClO4, that is perchlorate. I ate something icky, right? So we change it to perchloric and then acid. And that's it. Okay, let me come back up here. Number 3, change root if necessary for pronunciation. The only ones you're really going to do that on is phosphorus and sulfur. So any phosphorus polyatomic ions and any sulfur ions, you'll change those. Okay, with that being said, here's phosphate. All right, so PO4 with a -3 charge is phosphate ion. I ate something icky. We change it to IC, phosphic. It just sounds silly. So we phosphoric and then acid. Sounds so much scarier, right? Yes. All right, and then CO3 is carbonate. And I ate something icky, so it becomes carbonic acid. Now, remember, if I'm going too fast, you are watching this at home in the comfort of your bed or whatever. You have the ability to pause your teacher. You can rewind your teacher. You can turn me off for a second. You can rewatch it again. So if I'm going too fast, use that to your advantage. Okay, how do we write the formulas from the names? Well, we identify the elements involved. We have to see what's attached to the hydrogen. If the acid starts with hydro, if the name of it starts with hydro, then it's not a polyatomic ion. That means it is a non-metal on the periodic table, not a polyatomic ion. If the name does not have hydro in it and the acid name ends in IC, then the polyatomic ion name should end in ATE, right? I ate something icky. If there's no hydro in the name and the acid ends in OUS, then the polyatomic ion name must end in ITE. These are rules. You have to memorize these rules and you have to follow them if you want to be successful. Life lesson. Okay, if there is a prefix on the name of the acid, that means there has to be a prefix on the polyatomic ion name. So hypochlorous is hypochlorite. Prefix, it stays. Okay, and then you use the charge on the anion to determine how many hydrogens you should have in the formula. So, practice. We'll do the first 4. You do these 4 on your own, bring them back in, and we'll check them in class. All right, carbonic. First, is there hydro? No, so it has to be a polyatomic ion. IC gets changed to ATE. Carbonate is CO3 with a -2 charge. How many hydrogens do I need? 2, so H2CO3. Nitrous acid, no hydro, so it has to be a polyatomic ion. We change OUS to ITE. Nitrite is NO3 with a -1 charge. How many hydrogens? 1, HNO3. Sulfuric acid, no hydro, must be a polyatomic ion. IC gets changed to ATE. Is there a sulfurate? No, but there's a sulfate. All right, so sulfate, SO4 with a -2. How many hydrogens? 2. All right, last one we're going to do together, and then you do these and we'll check them in class. Hydrochloric acid. Oh, look, it has a hydro at the beginning. That means it's going to be hydrogen and a nonmetal. So hydrogen and a nonmetal. Chloric sounds like chlorine. What's the charge? -1. So HCl because I need one hydrogen. There you go. Try those other ones. Ooh, ooh, ooh. Okay, let's talk about hydrates. What in the world is a hydrate? Well, a hydrate is a compound that has a specific number of water molecules that are embedded in the crystal structure. Okay, so you have to show them in the chemical formula when you write it and when you say the name as well. So we have calcium acetate heptahydrate. That was a mouthful. That tells you here, this is the formula or this is the name of the compound. And this part tells you, look, it's a hydrate. There's waters associated with it. Okay, now, you could also have something that we call an anhydrous. Anhydrous just means that there's no water added to it. It's the pure crystal structure or form of the compound without waters embedded into it. So example would be if it just says calcium acetate. Or it could say anhydrous calcium acetate or calcium acetate anhydrous. So that way you know that there's no waters added into it. Now, typically you can tell the difference between an anhydrous and a hydrate based on characteristics of it. So for example, cobalt. Cobalt 2 chloride has this nice, pretty, characteristic blue color. Okay, if you've ever heard of the color cobalt blue, that's where it comes from. When you add waters to it, it becomes that nice pink color that's up here. It looks red, but it's actually pink in solution. It's very pretty. All right, so that's how you can tell the difference between especially these two right here. Now, how do we write the name from the formula? You're going to identify the ions involved because it's going to be an ionic compound. You cross down the charges just as you would any other time that you write the formula for an ionic compound. The only thing that's different, well, here, use parentheses. Okay, this is all the same. The only thing that's different is here at number 4. You have to identify the number of waters in a hydrate, and you're going to use a dot to show that you're multiplying, and you're going to use a prefix with the water formula. So here's your prefixes again. Let's do some examples. Magnesium sulfate heptahydrate. So there's magnesium, there's sulfate, and then there's hepta, which means 7, hydrate meaning water. Okay, so we take magnesium with a +2, sulfate with a -2, force field, cross them down. It becomes Mg2SO4 in parentheses with a 2. Can I simplify? Yes, only the 2's. So we put MgSO4 times 7H2O. And that's how you would write the formula, magnesium sulfate heptahydrate. All right, on this one, cobalt has a +2 charge. How do I know? Because it says so in the name. Chlorine, Cl, has a -1 charge. How do we know? Because of the periodic table. And then hexahydrate, 6 waters. All right, we have to cross these down. Do I need parentheses? Nope, because there's not a polyatomic ion. All right, so we rewrite this as CO1Cl2H6H2O. Do I need the 1? No. So CoCl2 times 6H2O. Okay, and to write the name, you would do the same thing as you would for writing an ionic compound's name, and then you would write hexahydrate or heptahydrate or dihydrate, whatever the prefix for the number of molecules would be. All right, and that is it, ladies and gentlemen. I will see you in class.